Hi guys, in this video we are going to talk about ARP. ARP basically stands for Address Resolution Protocol. The name itself indicates that it is a protocol which is used to resolve the address. The address here, it is talking about the MAC address. So let's discuss some points related to ARP. So the first point states that the ARP is used to resolve, or you can say that find the destination MAC address. So let's understand this point with the help of example. So here is an example wherein 4 PCs are connected to switch. So let's suppose PC1 wants to communicate to PC4. Let's suppose any type of communication. It wants to share a file or a picture or something. Okay, so now how the communication will happen. So I'm just going to talk about the network layer and the data link layer. So at the network layer, what will be the source IP used? The source IP will be 10.1.1. The destination IP will be 10.1.1.4. And what about the source MAC? The source MAC of PC1, that is 0A, and the destination MAC, which is of PC4. But right now we are assuming that the destination MAC address of PC4 is not known to PC1. So how it can forward the data? So it cannot forward the data until and unless this destination MAC address is resolved. So this data will be on hold. So now how the PC1 will going to resolve the destination MAC address, which is PC4? So for that, it is going to use a protocol called ARP. Okay, so ARP is always generated on Ethernet media. Okay, so now how the communication will happen? The PC1 is going to send an ARP request. It is going to send an ARP request. Okay, so ARP request is a layer 2 protocol. That means, let's suppose this is an ARP packet, so it will get encapsulated inside layer 2 header. So I'm indicating the ARP as A. This is an ARP packet which is encapsulated into layer 2 header, that is Ethernet header. So the source MAC is 0A. It's a small a, no issues. So the source MAC is 0A and the destination MAC will be broadcast. Okay, it's a broadcast. So this is your source and this is your destination MAC. Broadcast means all F will. Okay, now switch 1 is going to receive this ARP request on port number 1. Now the default behavior of switch says that whenever it receives and broadcast, it will forward the broadcast from all the ports except the one on which it is received. So it will send here, here and here. But this ARP request is actually generated for which IP? It is actually generated for 10.1.1.4. So now when PC2 and PC3 will read the ARP request, it will get to know that the ARP request is actually generated for 10.1.1.4. So they will simply drop this and they will not generate any ARP reply. But PC4 is going to generate an ARP reply for the received ARP request. So what will happen? It is going to generate an ARP. It is going to generate an ARP reply for PC1. So let's suppose this is your, again, this is your ARP reply. Now this packet is ARP reply. Now again it will get encapsulated into Ethernet header and the source MAC this time will be 0D and the destination will be 0A. So this is your source MAC and this is your destination MAC. Now switch will receive here. Now switch will perform unicast forwarding this time and it is going to forward the traffic out of port number 1 and the PC1 will get to know about the MAC address of PC4, that is 0D. Now this particular data can be forwarded because the MAC address is resolved. So I hope the ARP concept is clear to you. So whenever the destination MAC is not known, then the user is going to generate the ARP request and the IP for which the ARP request is generated will going to reply with the ARP reply. Okay, and then this is how the user will get to know about the destination MAC, and the communication can occur between the users. So, and one more thing guys, the ARP is always generated in same network. Okay, so, and the other thing is the ARP request is a broadcast, which I've already discussed, and this fourth point is ARP reply is always unicast. Okay guys, there is one more thing which I have not discussed in this example, so let me tell you. So when this ARP request, when the user 1 has sent the ARP request to this user, it is going to build an entry in its ARP table, so that in future whenever it wants to communicate to 10.1.1.1, the MAC address should be 0A. Similarly, PC1 will also make an entry in the ARP table that in future if it wants to communicate to this IP, the MAC address should be 0D. And these entries are maintained for 4 hours. Like after 4 hours, if these two machines will not communicate with each other, the entry will be deleted from the ARP table, and this is known as the aging time of ARP table. Okay, so this is what written here, that users builds entries of MAC address in ARP table and the aging time is of 4 hours. So thank you so much for watching this video.